Hello everyone. My name is Suryansh Tibrewal. Today I'm going to talk about talking to Amazon Alexa. So imagine you are having dinner with your family or your friends and you decide to plan your next vacation. It can be Amsterdam, Paris or whatever. And you have questions in your mind. What is the weather like? What's the best time to go? Where can I stay? What can I do? And because you're having dinner, you don't really want to take your phone out. And generally the conversations end at that point and the plan gets cancelled as usual. So in some years, we'll probably have a voice assistant which will be so used to talking that just say, Alexa, where can I go next? Book my trip. Now this software on that device can be anything by Amazon, by Google or by Apple. That software, whoever owns that software owns that vertical. And today I'm going to inspire you to own that software. So I'm a backend developer currently working in new product development at booking.com. I really love startups and following the new trends. So, and that's what piqued my interest in the voice ecosystem. So what is this talk about? I'm going to start with what is Alexa and why should we even care about it? How to develop a skill for Alexa, whatever a skill is. What are the challenges of developing on the voice platform, and to give you with some tools so that you are able to develop it. Okay, a quick show of hands. How many of you know what Alexa is? Nice. How many of you own an Alexa device? Or some other voice assistant device like Google Home or Apple HomePod? Okay, for some hands. And have you ever tried your hands developing something for these devices? Okay, 1, 2, cool. Okay, so this is a very beginner talk. It explains the concepts of how these ecosystems work and how you can get started. So I guess the crowd is right for it. Okay, so what is Alexa? Alexa is simply just a cloud-based voice assistant, which is used on smart home devices. Those smart home devices can be anything, including those Echo devices, which are very common. And these devices these voice assistant can be used to do various things like ordering food or getting to know about the weather or having just a simple conversation. So why do we even care about Alexa? Well, because next search engine is voice. 1 in every 4 searches on Google right now on a mobile device is done via voice. And just imagine, 10 years ago when the whole smartphone ecosystem came in, everyone was like, everyone who just got into that ecosystem early got the best advantage. Creating an app on an Android or an iPhone 10 to 15 years ago gave you such a big head start that those developers actually owned the platform. That time is there for voice right now. In US, 20% of the adult population own a smart speaker. So it's not really far ahead. It's actually happening right now. The user base is there. So, and why am I talking about Alexa? Why not about Google Home or just Apple HomePods? That's because the smart speaker market is owned by a majority by Amazon. Okay, so what is the skill? Skill is simply like, you can imagine it like an app for a phone. Skill is for Amazon Alexa devices. It's a basic 3-step process if you want to develop a skill. First, think of an idea. Think of what the conversations are going to sound like. Think of all possible iterations that what a user would say, what you would want to respond, how the conversation flows can work. Then just sit with someone, act like Alexa, and talk about it. And then actually develop it. So the common terminology used in voice ecosystem is voice user interface diagrams. It's just a bunch of flowcharts where you think of all possible conversations that can happen and you try to simulate what your skill wants to do. Now, after that, as I said, you can think of all things, but if you don't sit down and actually try to make it human enough, it feels very unnatural. So it's important, before even trying to develop something, just try to simulate the same conversation. Now, going into the details of how the whole life cycle of a skill works, imagine you have a voice device at home, for example, an echo device. You say, Alexa, something, something. So now this Alexa is a wake word. The voice device is always listening to whatever is being said around its field of listening, and whenever it hears Alexa, it just there is a system algorithm checking in within the device itself who tries to figure out whether Alexa has been said or not. Until then, everything else is gibberish for the device. So once that is decided, it sends to the external Amazon servers and confirms, okay, this is Alexa, wake word, and after that, it deciphers the rest of the voice input. Now that voice input could be, Alexa, ask PyCon PL, who is the keynote speaker. Now here, this voice to text is handled by the device itself. Now, if you are a developer, we face that while developing. Like, suppose you want to create like, I don't know, diary entry or something like that. So whatever values you get is after the device has done the voice to text translation. You're not getting the voice. So that voice to text is handled by the device itself. It could be your phone's Google Now or Siri or whatever. Whatever you get is the voice to text translation. Now, how does it decide that it has to communicate to an external server after getting this text message? Like, for example, Amazon Alexa could itself answer it. It could, and after that there are some flows like triggering a skill. That is called an invocation name. So, for example, if PyCon had made a skill and they had called it PyCon PL, now if a user says, ask PyCon PL, who is the keynote speaker, this PyCon PL is the invocation name, and now the Alexa server knows that I have to trigger the custom skill that was created. Now, after that, in the Alexa ecosystem, what you get in the text message, for example, who is the keynote speaker, it does the intent classification for you. So I'll show you an interaction model how we can do the intent classification on the platform itself. You get the intent and you get the slot value. Slot value is like, for example, if you tell me about Amsterdam. Now this city name can be your slot value. So you could ask, tell me about Paris, tell me about London. Now this intent and slot, that is what you get at your server side. This server side is basically an HTTP endpoint that you provide when you register your skill on the platform. After this intent and slot, you could just output like a simple response and it would work. But if you want to create an elaborate skill, you would probably want to have like a detailed state machine to have a conversation. State machines, is everyone familiar with it? Raise of hands. Okay, seems good. Yeah. I did it to some business people once and state machine wasn't so common. And so now after the state machine, when it decides, okay, what is the response, it sends it back to the Alexa server, and that server sends it back to the device, and device speaks it out to the user. Now, when you send the response, you also send whether you want to continue the conversation or not. So this should end the session flag decides whether the mic remains open or not. Like, okay, so this is the interaction model that I mentioned. So if we say, for example, speaker intent. Now here you can specify all the possible utterances that a user can say around that, like who is the keynote speaker. After you give all the possible utterances, the machine learning algorithm inside the device trains it to understand the patterns. It is not good enough. It depends like how many utterances you give. So if I give it like, who is the... Now this value inside the bracket is a slot. Here I can feed in what the slot values are. So give me an example that we faced. So we wanted to listen to tell me about a city name. So, and after that we also had things like tell me about Rijksmuseum, which can be like an attraction or something. So if you want to have multiple intents classifying the different kinds of named entities, the training becomes really important. So if in the slot value, you can actually give examples as to what it expects to listen in the slot. If if you give, like, for example, 10,000 examples, it can overtrain the system to just listen for that slot. And if you give 2 less, then it is not able to identify the named entity recognition. So it is important to have the right data set in this. Now, some of the challenges that we faced while developing this, it can happen on multiple levels. So, as I said before, when the device listens to it, it can just fail to recognize the speech in the right way. The system is improving, but that can actually happen. And while developing for the platform, you have to think of these scenarios when you are debugging and testing. Now, even if the speech was listened correctly, the invocation name trigger can fail. After that, if the intent classification, which I mentioned before, like tell me about Amsterdam and tell me about Rijksmuseum, can get confusing for the interaction model to understand. So it's important to think of different intents while creating. Like, for example, this could have been a single intent, and an NLP layer could have been there on the backend side to decide where to send the message. And when you are creating a state machine, every state has a context. Now, if you get a wrong intent at some point, you can lose the context and your system goes basically crazy. Now, there are many pitfalls. How can we, like while developing, how to handle those problems? One thing that we thought of while developing was, it's important to understand where the systems are failing. So if you have like a lot of flows already laid, conversational flows, and you decide to add one more thing and everything starts breaking, it's important to know what change did what. So that's why we did unit testing in a very easy way. So in Python, we used decorators, which basically captured whatever input we are sending to the function and the output coming out of the function. And for every function, for all the state functions, we used to store those input and outputs on a file. So in general website flows, where you have different buttons and user can click many things, these kind of test cases, automatic test case generation does not work. But for conversational interfaces like chatbots or voice conversations, these automatic test generation can work really well. So when you create a system, you can just do your normal conversations that you do while testing, and at the same time, you could record those conversations to generate your test cases, which in future makes your system very resilient. Now, my team had some experience before developing chatbots also. So it was a little interesting to get into that voice conversation mindset. And these are the problems that we mostly face. That like the NLP layer, as I said before, that there is a voice to text layer in between. And after that, a lot of platforms don't want to send you the exact text message. Google Assistant devices do send it to you, but Alexa does not. So the NLP layer, the control of the NLP layer is not in your hand a lot of times. So it gets important to be able to handle the errors that you can face in intent classification, which generally does not happen in chatbot. In chatbots, you generally get the free text format, like for example, if you are using Messenger chatbot. Then the other biggest, the interesting fact was context of the conversation. So if a user just stopped the conversation and came back few hours later on a Messenger chatbot, they can just scroll up and know what the conversation was about. But in voice, it's really difficult to do the continue where you left off feeling, like conveying where the conversation was going. So if you are creating like a transactional flow, for example, booking a room, it gets really difficult to do it on voice. Then the system is very synchronous in voice. So the system only triggers when the user starts a conversation. Imagine if you had a voice device who would just keep talking to you without you asking for it, then you wouldn't own it, right? So that's why these systems are made in a way that the conversations are very synchronous. But on the other side, on chat, it's very easy to send a message anytime on the system. Now, some tools which, from easy to complicated, which can help you create a skill. There's a very easy tool by Amazon called Blueprints, which allows you to create like simple Q&As or anything. It's called Blueprint. And you can have you can feed in question and answers in a very easy way. You cannot make like if-else, flow conditions, etc. Then there is a startup called Storyline. I think it's from Russia. This startup Storyline has a kind of like a flowchart generation, which you can create different flows on their web UI, and it generates a skill for you. but of course it is very limited. But if someone does not want to write a code, it can be a good option. The preferred option which I like to use is Python Flask class combination. It is a wrapper on the Flask library which integrates the Alexa SDK and helps you create, it handles all the API documentation which was done. And after that, we used transitions library for the state machine management. So if you integrate a state machine library and then you have like Flask class or Alexa FSM, it is not that complicated and it gives you a lot of control over the platform. You can literally manage the context on yourself instead of relying on the platform, for example. Now, to summarize the voice ecosystem, just think of a use case, think what is practical. Like, for example, you wouldn't order a shirt from a voice device easily because you generally want to see how the shirt looks like or what is the color and all those things. But for example, groceries can be a very good use case for ordering from voice. Now, actually sit down and think of all the ways that a user would want to talk to a device to solve this problem. After you have thought of it, sit with your friend and just try to talk like that. Then actually use a platform or get your hands dirty and do actual programming and get it ready. And then test this thing with the real users. Iterate very fast because this platform does not have really any standards right now. It is so untapped that it's impossible to know what the user is going to want unless you ask them. That's all I have to say. So, are you going to talk to Alexa today? Thank you.
We have a few questions. The first one, can Alexa have naughty skills? Or is it also censored as Apple does with his iStore?
Can Alexa have?
Naughty skills, so like sex tales.
They have a platform where they do a review when you submit a skill. I haven't tried the naughty skills to see if they censor it. So you have to try.
So you cannot have that. Okay. How does Alexa ensure search privacy?
Yeah, so for the privacy concern, as I mentioned before, you never get as a developer, you don't get the free text. You get the intent and particular slot values. So because of that, the data that you get on your side is very limited, and that's how they handle these search privacy concerns. What Amazon does with it, I have no idea.
Okay. Are the skills you develop private or are they shared with other Alexa users? Can you make Alexa offline only?
It's a platform, so of course the skills can be made public and you can share with your friends. And it goes on a public store. And if you just want to use it for internal purposes, there are two ways I think. One is to just release as a beta testing users, and the other is an Alexa organization thing which allows you to create, like for example, if you are an apartment owner or if you are in office and you want to have an Alexa device on your meeting rooms, and whatever you create you just want to be able to access from the office, then you can create that. And the other part of the question was? Are your skills developed private or are they shared? Can you make Alexa offline only? You cannot make it offline only because the natural language processing and the connection with the internet, everything happens on the server side. So I don't see how you can make it offline only. Okay. Unless you use a Raspberry Pi and create your own Alexa.
So, okay. How Alexa listens to keywords when music is playing?
Interesting. They have created something, literally. I have actually no idea what this means.
Okay. So developing a skill is on a website, you don't need to program anything?
As I said, there are two ways. Programming, of course, gives you all the control, but imagine like the storyline platform, you can imagine it like Wix.com. If someone who is not from a technical background wants to create something easily, then these platforms like Storyline or Groupin make sense. But if you want to actually create something which does something interesting enough, I think programming is very important for this, and I guess every one of us loves to do that, so no problem with that.
Can you make Alexa run a script for you?
Well, you could, because basically it calls an HTTP endpoint. So if you have a trigger word, for example, run my script or something, call XYZ skill to run my script, then it can call that skill, and on the HTTP endpoint you can trigger a function to run the script.
Does Amazon provide some tools to create more like AI-like experience, or do we have to stick with it's to create decision trees?
AI-like experience is a very broad term. There is a con of the platform. It only gives you intent and slots. So you have to define your intent and slots in a way that you can create that AI-like experience. There is a competition by Amazon where they give like $1 million or something who creates a conversation skill, who can hold a conversation on any topic for like 20 minutes. So that platform actually has scope. People are doing it and creating this. So it's not if-else decision trees. It just depends on the way you think about it.
Can Alexa be rooted or hacked or otherwise used without interacting with Amazon servers?
I haven't tried it. I haven't seen a YouTube video which done that, so it hasn't been done yet, but maybe you can try.
Is there Amazon or third-party Python library to interact with Alexa? Is it kept up to date with the API?
Yes, there is. There is one on Node.js, there is one on Python. I have seen these two, so these libraries are very well maintained.
Is Alexa better than Google Home to develop?
Personally, I feel from developer point of view, there is much more freedom on the Google Home platform. So Google Home, but concepts remain the same across both the devices. The biggest plus point Google Home has for developing is it also gives you the free text, not just intent and slots. It has an extra layer which allows you to get intent and slots from the Google device itself, but it also gives you the freedom. So that's the answer.
I have my own question. Does Alexa support push? So you can push to Alexa, not from
No, it's a full experience. There is for some cases you can do a push notification like a reminder or something, but it isn't the push the way you want.
How about recognition, not pure English accent?
For that, they have like English, like for example, English US, English UK, English India, and for some other countries also. So they have trained the natural language understanding for particular English accents, and they are starting in other languages also. Like a couple of months back, they released in France, and hopefully they'll release soon in Poland also.
Okay. Some example of using Alexa Python library.
I could share a GitHub repo or something around that if you want.
Do you have an example of Python algorithm, for example, that's the same, basically?
Yeah.
Why Alexa is so expensive, and how can I overcome the price point to test in my scenario?
You don't need a device to test these skills. You can do it on the platform itself, and there are other websites like EcoSim, etc., which allow you to do the testing from the website itself. And I think the device, they generally have like Christmas sales or something which gives like 30 euros, which is expensive, but if you think of it, can be a good gift. Maybe.
Okay.
Thank you.
Thank you.
Thank you.